The standard normal distribution is a special normal distribution with a mean of 0 and a deviation of 1. The normal distribution has different names in different aspects. In statistics, it is called normal curve, and in social science, it is called the bell curve, and in the physics, it is called Gaussian distributions. The empirical rule states that 99.7% of the data observed following a normal distribution lies within 3 standard deviations of the mean. Under this rule, 69% of the data falls within 1 standard deviation, and 95% within 2 standard deviations, and 99.7% within 3 standard deviations from the mean. This information can help you with the next challenges you'll be facing. If one group member passes one test, then the score is added to the group. Now, prepare as we're going to start.
This is a function that can take a discrete number of values, not necessarily finite. This is most often the non-negative integers or some subset of the non-negative integers. For example, when we flip a coin, there are only 2 possible outcomes, head or tails. When we roll a dice, we can only obtain one of 6 possible outcomes, like 1, 2, 3, 4, 5, or 6. Discrete probability functions. Next, this is a probability distribution in which the random variable x can take on any value is continuous. This distribution finds a large number of applications in statistical quality control. This type is used widely in the study of large number of applications in statistical quality control. This type is used widely in the study of large sample theory where normality is involved. This can also measure on a scale such as height, weight, temperature. Continuous probability distributions.
The score on an exam are normally distributed with a mean of 65 and a standard deviation of 9. Find the percent of the score between 70 and 86. Okay, glad I listened to that guy earlier. So the formula of transforming a score of observation x from any normal distribution to a standard normal score is z equals x minus mean divided by the standard deviation. With this, I will be using the less than cumulative tables. First is to transform the values of x1 and x2 into z values. So now we have the probability that x is between 70 and 86 is equals to the probability that z is between 5.6 and 2.33. So the area of the probability that z is between 5.6 and 2.33 would be the shaded area in the curve. Now, by looking at the z table, we can see that 2.33 is equal to 0.9901 and 0.56 resulted to 0.7123. Now, subtract both values. And now we have 0.2778 or 27.78%. Therefore, the percentage of the score in between 70 and 86 is 27.78%.
I don't really get it. Why do other groups always win when we have higher IQ than them?
Clearly, the reason why they are always winning over us is because of their number. Many heads are better than one, as they say.
So you're saying that the numbers of the members of the group affects the scores they've been getting?
The only way to know is through conducting correlation.
What's correlation again? Don't answer. I think I can remember it. Correlation is a statistical measure that expresses the extent to which 2 variables are linearly related, meaning they change together at a constant rate, right? So it's a common tool for describing simple relationship without making a statement about cause and effect. Correlation is used to describe the linear relationship between 2 continuous variables like weight and height. And also it has a scatter plot. It is a type of data display that shows the relationship between two numerical variables. Each member of the database gets plotted as a point whose x to y coordinates related to its values for two variables. It also has these three results: the positive correlation, negative correlation, and the no correlation. So which makes sense. With correlation, we'll know if the numbers of the members of the group really affects the attainment of high scores.
So, the question is there a relationship between the scores and the number of the member in every group? With this set of data, we can get the summation of all values. After getting all the sums, we can now interpret it using the formula. Substitute all the values, then solve. So, the result we got is 0.89. And by looking at the degree of correlation, we can conclude that there is a very positive relationship between the scores and the number of members in every group. So, what are you waiting for? Let's find some new member.
So we have recruited 5 more members of our group and now we are 12. Are we sure that this number we could now achieve more scored in the game?
One way to know, linear regression.
Linear what?
With a linear regression, we can predict a response to a given predictor value. It is a way to model a relationship between two sets of variables. The result is a linear regression equation that can be used to make predictions about data. The variable we want to predict is called the dependent variable, or sometimes the outcome variable. The variable we are using to predict the other variable's value is called the independent variable, or sometimes the predictor variable. Let me do it. With the following data with the numbers of members and scores in each group, what would be the predicted score we could get when we already have 12 members in the group? So first, we have to solve the b or the slope. There. Subsequently, get the a or the y-intercept. Go. Then lastly, compute at least square or also known as simple regression. So we'll get a probable score of at least there 13.88 or 14 after having 12 members.
14? 14, we definitely have to find more members.